Hello, welcome to Lunchtime BABLing. My name is Shea Brown. I'm the CEO of BABL AI. I'm also a fellow at For Humanity, which is a nonprofit that develops audit criteria for AI systems, and the executive director of the Algorithmic Bias Lab, which is the research arm of BABL. So today I'm going to talk a little bit about something different. So I've been talking in the past few weeks about bias audits, and this is sort of the hot topic recently because, in particular, in New York City, local law 144 has required bias audits starting January 1st, and so without surprise, people are interested in bias audits and what they are and how you might do them. But I want to talk today about risk assessments. And it's one of those things that is going to be required. So risk and impact assessments, and in particular, ethical risk and impact assessments is what I'm going to focus on. And it's one of those things that is going to be required by pretty much any law that governs AI that's being proposed either around the country or at the federal level and in the European Union is going to require some sort of risk or impact assessment for AI systems. And ideally, it's something that happens, even before you start developing a system. But for sure, if you already have one, then there's nothing to stop you from doing a risk or impact assessment during the process. And BABL has an audit specifically developed for New York City, and in that audit, one of the that we have criteria around risk and impact assessments. And we've gotten asked before, this is not part of the law. Why are you requiring this? And the answer is that it's very difficult if you're going to be testing a system for bias to do so in the absence of having thought carefully about the risks of bias in that system. And so I just wanted to walk through some of the process that we've done when we do risk and impact assessments, and a little bit of what we're kind of recommending as an easier version for companies to try, which is fairly low impact in terms of the amount of time it takes, but I think it can be quite illuminating. So as normal, I'm going to try to speak, not speak for very long. If you have any questions, feel free to use the Q&A. You can ask at any time, and then I'll talk. I'll address those at the end. And so what I'd like to do is, let me first talk before I share my screen. Let me first give you kind of the approach that BABL takes to this. We've done ethical risk and impact assessments for a number of systems, and it's one of the things that we found companies find most impactful. So a lot of times, the work that we've done, people have come to us because they're interested in a bias assessment. Like, they have because this is the thing you see always in the news. What people are worried about: biased algorithms causing harm. And we have a policy, and we have for several years now, that we won't undertake a bias assessment unless we're allowed to do a risk and impact assessment. So I keep saying risk and impact assessment. What's the difference between a risk assessment and impact assessment? The only difference in terms of how we characterize this is a risk can be something that's not realized. So there's a risk for potential harm, but it may not actually have impact because potentially that risk has been controlled for and mitigated in an appropriate way. And so we think a risk assessment is sort of a broader assessment of a system, really looking for all the ways in which it could potentially fail or potentially harm people. So let me start a step back and address the goals of what are you actually trying to do when you conduct one of these assessments. Well, the main goal is to identify ways in which a system, a socio-technical system, so that's the algorithm plus all of the ways in which that algorithm is used in a particular context, the ways in which that system could potentially negatively impact somebody. And so we're focusing on negative because that's typically the most worrisome. But it doesn't mean you have to totally focus on the negative. Sometimes there are positive things that might outweigh some potential negative things. And so you can indeed think both positive and negative outcomes as well. And so there's really two ways in which we can approach this. One is to think in terms of harm. So what are the potential harms that could happen? And another is to think in terms of interests or rights, like what are interests and rights that might potentially be infringed on. And so that's the main goal, is to figure out how can this algorithm potentially cause problems, and then how can we mitigate that. So the general process that we undertake when we do this, I'd say it's very fairly labor intensive, but there's a general flow, and the flow is you first have to identify all of the stakeholders, and that's the very first step. So who is it that interacts with this socio-technical system? And so typically what you would do is you'd have to get in a room, you'd have to brainstorm, you'd have to go talk to people who use the system, and really figure out where is the system impacting, where, who's touching the system in some way, who could potentially be impacted. And you come up with a list. And so this you can't limit yourself to just the end user. You have to think about the company, you have to think about people who are using the tool. And so generating this list takes some time. And if you're doing this, I'd keep in mind that this list should be dynamic. It should be something that you constantly update and you constantly reflect on, and think about whether there are sort of intersections of these groups that are important that you're missing. And so always sort of a critical self-reflection here. Now, it's also important to get as many diverse inputs as you can in the room when you're doing this, because you definitely need to not have any blind spots. You're always going to have blind spots, and you have to accept that, but keep fighting against those blind spots as much as possible. So once we have this list of stakeholders, which we will continue to update, then we have to start deciding whether we're going to focus on harms or interests. And harms tend to be kind of an easier place to go than interests. But we have done it before. We've started with interests, and like rights or interests, which are so important that they give rise to duties to other people to protect those. And so, you could even start with the fundamental human rights if you wanted to, and elucidate it that way. But harms tend to be really obvious, or more obvious to pinpoint. And so start coming up with harms that the system could potentially cause. Now, at the same time, you need to start thinking about causes for those harms. So, and I would recommend doing this at the exact same time. So if you could imagine, if you're brainstorming, you have this list of stakeholders, and then you want to start generating what are the potential harms that could happen to these stakeholders. Sometimes it's easier in the moment to start thinking about potential causes of harms, like ways in which an algorithm could fail, or ways in which there could be misinterpretation of an algorithm by a person who's using that algorithm. And so you kind of have to keep those two things going at the same time. And so literally having a list with harms, and having a list of potential causes of those harms going at the same time can really be useful. And you can start generating more ideas that way. And so as you're doing this, let me step back one more second, actually, because I should have mentioned this in the beginning. Before you do any of this, probably the first thing that you need to do is to get a full context of the algorithmic system or the socio-technical system. So I missed this. I should be paying attention to my notes. And the reason being is that all of this is very context dependent. And so an algorithm that's used to identify somebody who's shoplifting in a store is going to have a very different sort of potential harm profile than an algorithm that's used to allow somebody into or out of some secure facility or something like this. Those are the two very different things. Even if the underlying technology might be similar in a lot of ways, those are two very different contexts. And so we actually have a methodology at BABL that we use. I wouldn't say formally use, but it's sort of a rule of thumb, which we call the CIDA narrative. So CIDA. And it basically says, C is for context. So elucidating to the fullest extent possible what the context of this algorithm is. So where is it being used? That includes who's using it, who it's being used on, let's say. Picture, the painting the most detailed picture of this algorithm as possible. That's what the context is. And that takes a lot of understanding. You can also think, if anyone knows anything about like an explainability statement, oftentimes those look very similar to what this context is. And then there's the algorithmic part, which there's inputs to that algorithm. So the I is the inputs. And so what data is collected? How is it collected? How does it get fed into the system? What are the filter effects? And I've talked about this in previous webinars about filter effects and how the way you collect data could potentially be causing bias or in some cases causes harm or exclusion. And so you have to understand that input process and that filtering process. Then there's the D, which is the decision procedure. So there's actual computation. So this is the algorithm part. So what actually gets computed and what's the output? And how does it get computed is also very important. And that's something that bias assessments can and often do focus on. And then from the output of that algorithm, there is some action that is taken, right? It's almost never that there's just some number pops out and then nothing happens, right? That would be kind of a useless algorithm. Some number pops out and something happens with that number or some output or classification. And so understanding what are the actions that are taken from that output, from that decision procedure, and what are the range of actions that can happen. And a lot of that has the sort of socio-technical aspect to it. Who is it that does that action and under what circumstances. So having that kind of picture is a really good first step. And you won't have all of the pieces of that picture, that CIDA narrative, but it's good to have that in hand so you know exactly what situation and context you're talking about. Okay, now back to the harms and the cause of the harms. And so essentially what you are doing is generating as much as possible a complete list as you can of the potential harms and potential causes of those harms. And here, again, diversity is important, and diversity of information and perspective is important. You have to kind of generate this list as faithfully as possible and try to be as complete as possible. And this is where you could do this all in one workshop, let's say, which has happened before, that we have done this in a single sitting. But we've only ever done that in cases where we've already done extensive research and interviews, and there are people who in the room who have extremely deep knowledge about the socio-technical system from, let's say, from interviewing people who built the system, from interviewing and taking notes, people who have been impacted by the system, interviewing and taking notes and having an understanding of policies and procedures that people who use the system use to, let's say, take action based on the outputs. And so it's better if you have all of that knowledge on hand when you're doing this. If you don't, you can still do this process and then go reflect back on what you don't understand and then go find that and then come back and do it again. But you do need to have as complete a list as possible of those two things. So now let's say you've generated this list. You have a list of harms and you have a list of potential causes of harms, and you have some faith that you've done a good job, or as good as you can, of making that a fairly complete list. Then what you need to do is start looking at comparing those two lists. And so in particular, identifying gaps is important. So if I have a harm, something that I see put down as a harm. So the algorithm has somehow harmed someone, but you don't have a cause for that harm, like a direct cause for that harm. You have to start digging around and think, like, why did I think that was a potential harm? What gives rise to that harm? So you need to fill in that gap. And similarly, if you have a way in which an algorithmic system can fail, so this is on the cause section, you know that it could potentially fail, right? Let's say one of the engineers in the room says, I know this is a common failure mode, and this may have some downstream effects, but then you don't have any potential harms or impacts on the other side. You start reflecting on, why is that? Are there things that I'm missing on the harm side? Or is it that the context of the way in which we use this system, there are controls in place which mitigate that, and that there's not a likely harm that happens from this. And as you do this, you often are going to reflect on a lot of hypotheticals. So let's say there's a cause, that a way in which the algorithm can fail. You don't have any harms associated with that. And let's say you've identified that's because we have some controls, let's say a human in the loop. And that human in the loop, which is a very common control that you might put in place or might be in place. So there might be a human reviewing this, and it's unlikely, or at least in your initial estimation, it was unlikely that this would actually propagate to a real harm on the other end. Then you need to start challenging those assumptions. What would it take for that control to fail? And oftentimes what you'll find is that you can come up with ways in which you can shore up that control. That you can do something differently, maybe communicate, maybe it's through education, maybe it's through a user interface or something like this, that will make that control more powerful at mitigating that a potential downstream harm which you had ignored. So this process of connecting the dots between those two tends to be really illuminating, and it starts bringing out things which are really relevant for risk in this system. Okay, so after this process, so let's say you've completed this process. Now you have a list of harms, you have a list of causes of those harms. They're all connected, and in some case they are not connected because you think you have appropriate controls. Then what you're able to do is you can start thinking about mitigation strategies, because you have a failure mode or you have some cause on one side. And maybe I should give some examples. So one obvious cause of harm is bias, right? So we've been talking about bias for several weeks now. And so it's pretty obvious that if an algorithm works differently for one group than it does for another group, that's sort of the definition of bias, or at least societal bias in the way that we categorize it. That's clearly a cause which everyone should consider in their algorithm. That's one of the top things on the list that you need to consider. But there could be other things. It could be cause might be a misunderstanding. So it might be that a person sees an output, person has to make a decision and take an action based on that output. But if the person interprets it in an incorrect way, there could be an adverse outcome for someone. There could be a harm that happens at the other end. And so harms don't have to be, or causes of harms rather, don't have to be technical in nature. They can be socio-technical. And I can say from experience, having done many of these now, your list is going to be made mostly of these socio-technical causes. A lot of what happens, where the risk happens, is that place where there's an interface between the technology, that decision procedure, and the actions that are taken typically by people, where you're going to have a lot of potential for risk. Which is why it makes so much sense in all of the typical guidelines for, I wouldn't say typical, emerging guidelines for responsible AI, that things like training and explainability, those sorts of interventions are so important because they give rise to risk. But going through a process like this allows you to make those connections in a lot more robust way. So when you have these causes that could potentially give rise to harm, the question is, how do you mitigate that? And that's where a lot of the hard work and a lot of the really important work happens in these risk assessments. Is now you can identify, all right, if my algorithm gives me inconsistent results based on unexpected inputs, so this is sort of on the robustness side of the algorithm. How do we control for that? How do we test for it? How do we monitor it? And how do we, in the end, mitigate the potential for that to happen? And this is really the power of these risk assessments, is that it gives you a set of tools and a sort of snapshot and a picture of the algorithmic system that is going to allow you to take those interventions and really mitigate the risk. So, and that's also the fun work, because then you can, when you're doing that, that's where you're getting a lot of value from this process. That's where you are making your system more robust, less bias, more just better for humans. And so that's why we require this. That's why we think that risk assessments should be done by every company that makes AI or that uses AI. And it doesn't have to be a sort of heavy, onerous process. So the process that I described to you now, typically when our firm does this, it involves a lot of stakeholder interviews. And so we get into a company, we have to understand how the system works. So this is sort of constructing that CIDA narrative, make sure we have every piece of the puzzle, or at least as many as we can, to really understand where can this system affect people, how is it used, what are the sort of use cases. And then we have to talk to a lot of groups. And, so you have to contact stakeholders, oftentimes external stakeholders. And we think that's really important, to talk to impacted groups and talk to people who use the algorithm. So this is a very intense process. And then there's a whole analysis, and we go through exactly what I just mentioned in terms of a procedure once we have all of that information. But if you're just a company that has, a bunch of developers, product people, you've got a legal team, the easiest thing to do is to literally just call a meeting and give yourself a few hours, which is expensive and that takes a lot of time and it's hard to do. But give yourself a few hours and get in a room with sort of as diverse a group as you can. And if it's just people from your company and that's all you can do, doesn't mean you shouldn't do it because you can't get external stakeholders. It's still worth doing. Get the people in the room and go through this exact procedure. So define the context. Okay, what algorithms are we using? Let's make sure we understand all the ways in which those algorithms are used, and understand the full context. How does it work? Make sure there are people in the room who understand how it works. Make sure there's people in the room who understand how it's used, and hopefully make sure there are people who understand sort of what external stakeholders might perceive or how they experience the algorithm. Then you're going to start thinking about all of the stakeholders. And so you're going to start generating that list of stakeholders. You're going to start generating that list of potential harms associated with these stakeholders. And at the same time, you're generating this list of potential causes of those harms. That's a process that can happen dynamically. Get up on a whiteboard, start writing those things down. Everyone's got input. Let's change things as we get new ideas. Once we have these lists generated, then there's the process of connecting the dots between those causes and harms. Once you have that finished, you look for gaps there, try to fill in all the gaps, causes that don't have any harms and harms that don't have causes. And then you have a list of causes, which you now need to say, how can we mitigate those causes? How can we keep those from happening? If we can't mitigate them, are there other ways that, let's document the fact that we can't and try to come up with some way in the future to mitigate that in some way. And importantly, if you're doing this, keep good notes, because that's something that we'd like to see that process play out. And it's going to be something that is going to be required in the future. I think all the guidelines coming out and all of the new regulations explicitly point to risk and impact assessments as being something that companies should be doing. And so getting in that habit now in this sort of light, version of it can't be anything but good. Okay, we have we have cheat sheets associated with this, and so if anyone listening is interested in getting one of these cheat sheets that talks about, we have them for bias assessment. We also have them for risk and impact assessments that sort of outline in a very bullet point way what I just said. Let us know, and we're happy to provide those. So let me see if anything has popped up in the Q&A. Hopefully maybe I was so clear that nobody has any questions. Okay, so somebody does say, can risk assessment be an automated process? So our firm is using AI governance platform that gives us automated risk assessments. So, okay, let me be careful in my answer here. They can be an automated process. Whether they should be an automated process is another story. I think that there is some hard work that has to be done initially to fully understand the context of your algorithmic system and how it's being used. A lot of these socio-technical issues that I just mentioned, it's hard to capture them in an automatic risk assessment. That doesn't mean you can't necessarily do it, and that an automated risk assessment can't be a good flag for danger, where let's say you're using a particular type of algorithm in a particular setting, and let's say you don't have governance policies over that particular use case. These automated systems are good at flagging that sort of thing, where, and if it's integrated into your organization in a way that is robust, where people, let's say there's oversight and there are people who are going through a workflow and they have to get approval, maybe checking a box that says a risk assessment has been done, or documenting their data, or bias assessments and that kind of thing. Absolutely. But you do have to be aware of the limitations, and that automation has to be supported by careful thought initially. And once you sort of go through all of these issues and have it all set up in a way that is relevant for your organization and how you use data and how you use AI, then absolutely you want to find efficiencies as much as possible. But if you haven't done a process that is similar to what I just described, even if it's a couple of hours in a room talking about this, I think it's hard to get away with automating that unless you've done something of that nature. And then in terms of oversight, I think it's important that there be an oversight function which, at least at times, goes through a similar process. So a very common policy and procedure that we recommend to organizations is a review process. So risk assessments, yes. There has to be a trigger that will say we need to do reassess that risk in some way. And there needs to be a body or a group of people, or a person at least, who's kind of responsible for making sure that happens, or actually doing that risk assessment. And so it's likely that this type of thinking and this type of procedure is going to happen within an organization, even if you have it all automated. I think there's no way of setting up an organization such that it's fully automated, and there's never a time where it's sort of reflected back on in a way that is similar to what I just described. Okay, so I have another comment. NIST is publishing a risk management framework. I'm curious to know what your thoughts are on it. I think it's really good, and so we submitted some comments to it, but it's a really good framework. It's a good start, and it's something to be built on. The nice thing about the NIST framework as it's currently has evolved, like the newest version, is that they focus a lot on the socio-technical risk. And so in my mind, that's a really big improvement on previous versions and other kind of other guidelines for doing these sorts of things is that they really honed in on the socio-technical risk. So where people interact with the algorithms. And it's all, in my mind, the NIST framework is a good one. Do I agree with all the taxonomy that they use and the way they think about things like in detail? Not necessarily, but then I may not also be right, and my way of thinking about it may not be the right way to think about it. And so in the absence of anything else, or even in the presence of some other frameworks, the NIST framework is very good, actually. All right, so it's 1:30 now, unless I see another question, which I do not. Thank you so much for joining us, and this has been a fun experience for me, and hopefully we're going to, not hopefully, we're going to dive back into bias starting next week, and start getting a little bit more technical and giving some guidance as to some of the gray areas where, in particular, if you don't have demographic information to look for bias, what are the options you have available to you, and how can you proceed in the presence of this this problem, which is you may not have appropriate demographic information in order to do the testing, and in some cases it may even be against best practices to collect that information. And so next week and in future weeks, we're going to start getting a little bit more technical. As always, thank you for joining me, and let me know if you have any questions, and I'll be sure to hand out any of those cheat sheets if anyone wants it. Thank you. Have a good day.